Am I audible?
Yes.
Yes.
Great. So this is the NIWeek mobile app. I'm sure you've all seen and either chosen to use it or not by now. So here's a slide telling you about it. And good morning, everyone. Thank you for coming to our session. It's really exciting to see so many people here. I'm Christian Butcher. I'm a technician in a fluid mechanics lab in the Okinawa Institute of Science and Technology in Okinawa, Japan. So mostly I work on a Taylor-Couette experiment, which is a pair of concentric rotating cylinders, and we fill the gap with water, and then we make a variety of measurements, like load cell measurements, temperature measurements. We control the rotation speed and then measure it with rotary encoders. We have temperature control. We make velocity profile measurements with this laser system here. In the future, we might consider taking photographs and doing PIV, which is particle image velocimetry, basically comparing photos now and photos in a small amount of time and seeing what moved where. So there's quite a few different components that we want to measure and correlate and put together. And I started with LabVIEW about 2 years ago and used the continuous measurement and logging template. This is a pretty nice template. It has a lot of comments and things to help you get started. But it became clear to me as I added more and more of these measurements that my kind of main VI was going to get increasingly complicated. It was becoming harder and harder to work out, where to shove the next thing into this kind of increasing mess. And I didn't want to keep going along that road, so I looked around for alternative possibilities. And I found the active framework, which looked like it would be a good choice. So these are some bullet points taken from the white paper about the active framework, written by Alan C. Smith and Stephen Mercer, titled Using the Active Framework in LabVIEW. And I'm just going to go through them more or less in turn. So the first two are supports the writing of applications in which multiple VIs run independently while communicating with each other. And the second is each actor carries out an independent task. So the combination of these kind of ideas allows me to easily modularize my system and kind of conceptually envisage which things might be grouped together as a cohesive unit and could be considered a possible actor. And this kind of breaking up of the system into different parts is really useful for trying to make your code a little bit more reusable, which is something I'm going to be talking about for most of my presentation. The active framework mitigates the risk of deadlocks and race conditions. I'm not going to talk about this, but this is really important given that the system is very asynchronous. There's a lot of messages going backwards and forwards, and provided you follow some guidelines that they set out in this white paper, it's easy to reduce the risk that you're going to deadlock your actors and have them waiting on each other. Maximize code reuse. This is basically breaking things into modules and working out what you can share between one module and another module, and reduce coupling between modules. If you didn't see them, then you should check the videos with Casey and Alan's presentations yesterday, because they both covered coupling really well. So I'm going to start with some kind of quick bullet points on code reuse. My first suggestion is that the single responsibility principle is pretty important. The single responsibility principle, for people who aren't familiar, is the first of 5 principles popularized by Bob Martin, collectively named the solid principles. And so it's usually written either as a class should have only a single responsibility, or a class should have only a single reason to change. As a concept, this seems quite simple, but if you consider it a rule or a guideline or something, it's also quite easy to break. It's fairly easy to keep just adding a little bit more to your class until you have a class that does 5 or 6 things. And at that point, you're going to struggle to reuse it for anything apart from whatever you wrote it to do. And the second principle I'm going to touch on briefly is the Liskov substitution principle, which basically says don't break promises that your parents made. If you have a class inheritance hierarchy, your children should do something that isn't going to surprise people who expected some behavior from the parent class. So, as I suggested, classes with a single purpose can be easily reused. If it only does one thing, every time you need to do that one thing, you can take the class that you've already written and put it in there. If you start adding more and more things, it becomes harder to reuse that because now you need to be able to do all of those things in the position that you're trying to put this class. An example might be if I have some sort of data logging class and I decide that I'm going to have open, log data, and close as my interface to that class. This is fine. But if I then decide I want to add some sort of automated file naming, I might decide now I'm always going to want to date time stamp my files. And so my open file will now have some get date time in seconds and format it in some way and then name the file based on that. But my problem then becomes if I want to open another file later or I want to open the same file, I have a different time, so maybe I'll get a different file. Perhaps I wanted the same file to read some more data. If I have some variation in my plan and I decide that now I want a different format or I want to do something different, I can't easily replace that functionality with some other representation of that, naming responsibility. So in that case, even though it would be a really kind of small and trivial class, you could have a separate thing that does your create name from root path or something. The same applies to individual VIs, but here we have to kind of balance with usability. If we make VIs that do literally only one thing, then it might be that your API grows to 20 VIs and then it's really hard to use. So here we have to kind of consider the sort of level of granularity that we're interested in and trying to group things appropriately so that if you're always going to want to do things together, they can be together. But if you maybe want to do some things together sometimes and not other times, perhaps you should break those into two different VIs. This is an example of some code I wrote early on, mostly for the continuous logging, measurement and logging template. But then I kind of ported it into my actor framework. And while I was trying to do this, I realized it was really hard for me to write an actor around this because there's a bunch of stuff going on and I didn't remember, even though it was only a few months ago, what some of these lines were about. Are the clusters coming out of this really important or are they just as empty inputs? For actor framework, this makes quite a big difference because if I want to get outputs from something, I need a reply message probably, or at least some sort of communication method which increases my deadlocking chances. Whereas if they're only going to be duplicates of the inputs, I can just get rid of them. And here I have 3 palettes in multiple sections. Some of these things seem like unreasonable dependencies. This VI would crash if I didn't have a message queue attached to it, even though the message queue does nothing except display a status, which isn't really a crucial part. And here I'm using SPI start all to read my temperatures, even though I also have an SPI read all results over here. And if I hadn't written this, and frequently, even though I had written this, I would go back and have to open these guys and be like, why did I do this? Which order are these supposed to be in? Is there some dependency? Let me read the context help again. And it's easy, really. It didn't take very long to refactor this into a much simpler API. So here I have a class that does SPI communications, and it has init, swap, and close the children to inherit and override. And then 2 static dispatch methods, write only and read only, that are both implemented in terms of swap. I have 2 more VIs in a red box at the top. These are reset and wait for interrupt. These aren't really a common part of an SPI protocol or anything. I implemented them as part of this interface originally because I needed them for this printed circuit board that I was communicating with. And I wanted to make it a little bit easier to replace functionality kind of like for like. It's possible since Service Pack 1, 2017, although I hadn't quite managed to make it work until last night, that you can replace these with malleable VIs and have some sort of mix-in kind of effect. So then I removed them from the parent interface at least. But now I have init all, read temperatures, and close. And that's a much more common workflow that I think people would be used to. As my next learning point, I'm going to talk about using an interface in terms of designing your classes. Here, I'm just talking about a kind of abstract class that other things can inherit from, which isn't quite the same concept as like a computer science interface. It's reasonably simple. You just create a class and then some largely abstract methods, and then you inherit and override those with some specific functionality for your concrete children. And I wanted to improve my code reuse and make things more similar. So I created a measurement actor class, which gives me one API that I can use for all of my different types of measurements, or at least nearly all of my different types of measurements. This helps me reduce the learning curve, and also helps me reduce my kind of relearning curve when I look at something and I'm wondering, why did I write this? How is it going? Which is this VI here or there? Now I have only a small set of VIs that all of them operate with. So these use the template method in parts to force execution of specific parent code. The template method, I'm going to show an example from the actor framework on the next slide, is basically having some dynamic dispatch method, maybe, inside a static dispatch method, and then calling other things around that to enforce ordering or ensure that things are done in a specific order. This is more helpful than using the checkbox for must call parent node or something, because although I can say children must override this and they must call the parent, that doesn't tell me anything about whether they're going to call the parent at the beginning of the VI, at the end of the VI, and maybe I have some dependence that says they must call it at this part or this other part. So if I do this, I can put things in exactly the order I want. I don't have to rely on context help and people reading the documentation to make sure that they actually do it in the order that I expected. Another benefit of the kind of idea of an inheritance-based interface is that I can use it to build a plugin system. So this is actor.vi. I've blurred out most of it, but in the blurred sections, there are a bunch of different kind of concepts going on. These are all framework ideas. They're not important to the user, usually. At the beginning, we're creating some queues and adding some debugging code. There's a counter here that's incremented and decremented at the end to ensure that the runtime target doesn't destroy your things when it's not expected to. And I'm just going to zoom in on this middle section. This is pre-launch init on the left and active core on the right. And these are pretty much the only parts of this that you're likely to override as a user. And so this kind of structure with active VI, which you can't override, and then a couple of VIs inside that you can override, allows the framework to force you to do things in a specific order or to behave in a specific way. Some restrictions on using an interface-based, an inheritance-based interface are that you can't really make calls to any specific child VIs anymore. If you start doing this, you're going to immediately change your wire type, and then you can't say that it's part of the same parent class. This wasn't immediately obvious to me when I started writing this code, and perhaps it's fairly obvious in hindsight, but it's worth noting that if you can't fit something into the kind of interface that you've made available, perhaps it shouldn't be a child of that interface. All measurements need to be written in a way that fits this API. So for example, my laser Doppler velocimetry, the laser probe that we saw at the beginning, this has a large number of settings, and it kind of interfaces in different ways. You can't really make a continuous measurement in quite the same way. You just start it, and it runs for some time until it has a certain number of samples, and then it stops. Because it doesn't behave in the same way as some of my other measurements, I can't make it a part of this interface if I want my interface to behave in a reasonable way. If you start using an interface, it's possible that some of your changes will break any dependent code. For me, that is not a huge problem because I write most of the dependent code as well, but it's something to be aware of, so try not to make breaking changes if you're going to do this. The kind of corollary is that it can be difficult to get right the first time. So there are some things you can do to try and design to allow better extension, including the other solid principles. If you aren't familiar with those, John McBee and Stephen Mercer did a couple of talks over 2014, 2015 in NIWeek, I think. And they have videos available. And they cover it in quite a lot more detail. I found unit and integration testing. And I do integration testing with a unit testing tool, but I guess once you start including more things, it ceases to be a unit test. I found that these are helpful to prototype interfaces. If I discover that I'm trying to write the same code over and over again in my unit tests, and it's something that I think really should be always done with this interface, maybe I know it's time to try and modify my interface or make this operation easier to carry out. if there are some things that I never really want to use and writing tests for them is really difficult, perhaps they shouldn't be part of the public interface. So a final point is that initially I did all of my development for this project in one project file. This is not a great idea. If you have multiple modules, you should use multiple project files, because you make your dependencies much more explicit once you start loading things from different projects. If you do it all in one project, you can very easily end up with very tightly coupled actors and not really be conscious of that coupling until you think about it some more when you try and move them. Moving modules into separate project files makes dependencies explicit. You can see them at the bottom under the dependencies list. And making changes to those projects and rebuilding and reinstalling them makes it a conscious choice to change your interface. So just a quick summary. I would suggest that you shouldn't be afraid if a class is too small. Especially if you're using Active Framework, you can very easily end up with a really large number of files on your disk. But this doesn't have to be like such a terrible problem. Don't worry that your class only has 3 or 4 VIs. If it does one thing and it does it well, then it's a good class. To break separate functionality into separate classes, this is a follow-on from the same point. If I have a class that does 5 things, then maybe having 5 classes that were all a bit smaller and easier to understand, easier to describe, would be more useful in terms of reuse or just understanding. If a section of code should be reusable, write it in a separate project file. This is the same idea again that we just touched on in the previous slide. If I write things in a separate project file, it becomes obvious that I've made some explicit interface and I can see how I want to reuse it. If I just do it in the same place, then I'm going to end up trying to drag things around, and that's not going to be great. Consider the template method and the non-virtual interface idiom. This is a C++ terminology. I don't think that there is an equivalent in LabVIEW, but basically the idea would be to make your dynamic dispatch methods maybe protected, and your static dispatching methods provide the interface for that class. The template methods we looked through, and this is kind of tied to the same concept, that you might want to have static dispatch methods that form some basic structure, and some dynamic dispatch methods that they call, which provide the functionality. Call reuse modules only through the shared interface. This just allows you to keep using them as part of that interface. And use unit and integration testing to check the suitability of an interface or API. By having at least one caller before you start trying to publish your things, you can check that they're not completely unreasonable. I've still made plenty of not ideal choices even doing this, but probably fewer than I would have made otherwise. So that's the end of my presentation. Does anyone have any questions specifically on this? I think we're going to take questions at the end for both presentations. But
So, swap mics. Oh, thanks. Can everybody hear me? Yeah? Okay, cool. So, coming to the second part of the presentation. My name is Wachno. I'm from Germany. I have 2 jobs, having my daytime job, let's start like that, at the Bürgerwerke GmbH. We are producing control and process equipment for automation, so we'll see some pictures later on. I'm doing some production tests there, and I'm part-time self-employed. This is the first company, the Ingenieurbüro, doing coaching and training for NI-based solutions, so test and LabVIEW and so on. This presentation is a little is a hybrid. So I'm here on cost of the Ingenieurbüro, but having a presentation on a topic from Burkhardt. So don't confuse that too much. Anyway, yeah. But this is what happened to me during my daytime job. Let's talk about a software project with proper planning, clear requirements, proper choice of architecture, sounds fine. Structured code design and reviews, unit testing. Sounds good to start with, but unfortunately that's not my story. Let's talk about the real life, how it went, and it's called From Quick Coding to Clean Code. Yeah, let's see how that goes. Caution, there's some more sarcasm intended to be found during the presentation, so yeah. Let's go with the marketing slide. So what's that thing is all about? 2 or 3 years ago, Urquhart released a platform called EDIP, Efficient Device Integration Platform. Names like this is what you get if you let a German engineer make up some fancy marketing names. What's behind? We tried to unify the communication between all the devices, or most of the devices that we produce. That's, for example, here, that's mass flow controllers, liquid flow controllers, I/O systems, digital interface. No, that's the field was mine. We'll come to that later. Water monitoring looks like an upright down microwave, but in fact it's a water monitoring system. Control heads for valves, flow meters, valve islands, electromagnetic valves. Sorry, electric powered valves, not electromagnetic valves. Sorry. And to connect all these devices up, to be able to talk to each other, we have taken the can open concept, expanded that one, and have created a dialect, a proprietary dialect we call BÜS, because Burkhardt, we have that Ü in there, so there's called BÜS. Okay. So we can link up all those devices, connect up all those devices, but nevertheless, there has to be some way to communicate with the outside world, because the PLC probably don't want to talk that special can open dialect. So we have so-called field bus modules that interface all the devices connected to the bus to Ethernet-based protocols. So that's the concept behind that. So why did we have, or why did we create the can open dialect? Was just to give some more comfort, some more convenience in using the can open concept. Who here is familiar with can open? Okay. Just for me to know. Yeah, because can open really requires some kind of administration when trying to address the nodes, plugging new nodes onto the network, switching between different operational modes, and that's what this our dialect, our separate layer, really alleviates, makes it easier to use. And not to forget, we have a computer software called the Burkhardt Communicator, which enables us to go with an inexpensive USB stick to this can open, to this bus, to this bus, and parameterize all the devices, the device nodes, as I will call them, during this presentation. The communicator looks quite like, let's say like the Max. It's the NI Max. That's probably the same functionality. So I left myself behind. One feature we're going to talk about later is that those device nodes that are being plugged onto this bus are self-addressed, so they pick their own address. They can pick their own address, which is not the same thing that in can open, which makes it easier for the user to hook them up. So they can be dynamically put onto the bus and taken from the bus. Okay. As I said, the regular interface for the customer is the field bus module, but maybe we could use a LabVIEW driver connecting directly to that bus, to that backbone. Why? Well, R&D wants to play a little bit with that, with what they want, what they created. production would be also cool to talk to the devices under test. And maybe even there might be customers who want to use that strange drawing, colorful thing that's called LabVIEW. It was more or less one of the comments I got from one of the marketing guys. So he was not fully aware of, anyway. Yeah, but as life goes, R&D was like, oh, we should have that, but we don't have the resources. Production side of me was like, yeah, we should have this, but I don't have the resources. Now, I didn't like to do that anyway, I'm honest. So somebody came up with a brilliant idea of hiring a student.
What could go wrong?
Pardon that?
What could go wrong?
What could go wrong? Yeah, exactly. Because this guy was really ambitious. He was really willing to rock this. So he was given some requirements, or require what, as I like to say. So that was what he was given. So he should give up for failure. Yeah, it was kind of predetermined, yeah, but nevertheless. So this thing should be able to communicate with all device nodes hooked up to the bus. Meaning, you plug them in, it should automatically detect them, and if this device node is not connected, should give an error. Things like that. It should be able to read and write the SDOs, the status data objects, and the PDOs. Going to the can open, that's can open basically. So the SDOs is data that you go to the bus and ask the device to give you the data. The PDO, the process data objects, are published by the device node every 100 milliseconds, whatever you configure it to do. So it should be able to read both of them. And it should be usable like a standard LabVIEW driver. So open, close, read, write, just as you know it with any DMM. Yeah, we had some constraints. I'm just explain them a little bit and not go too much into the details. This driver was to reuse some parts of the functionality of the communicator, of program modules that come with the communicator. For example, this uses a socket server to communicate with the bus, and this is started by an executable. So launching an asynchronous executable, that was one. And there was we even had a DLL interface available, because some of this stuff was already used on C-based test equipment. So he had to use these DLLs, or this DLL, and use these calls, which also consisted of using callbacks, DLL callbacks. You have to translate them, LabVIEW, into dynamic use events. And he was not to rebuild the communicator software, so not reading in electronic data sheets, not giving any kind of convenience. We just wanted to have a trial. There might be software projects starting with less than that, but anyway, it was not really. Indeed, it was not really fair to give that guy that much, that little. Yeah, he was willing to do that. He was willing to try, and so time passed. We had some code reviews, looked into the some tests on the software, and it's not my intention to wash any dirty laundry here, but he was not the most gifted programmer. So, master thesis finished. We had some code that was kind of working, yeah, but as you know, the world turns, it goes round and round, and new things appear on the horizon. For example, there even had been customers asking for a LabVIEW driver, for a LabWhat driver, yeah. And fortunately, we had a change in production test strategy, which I appreciate, but that meant we had to go with a BIS device also on the LabVIEW-based test equipment. So I needed the driver myself. So we saw the transition, from SAP to MVPP. Anybody familiar with that? That's when you go from someone else's problem to my very personal problem. I guess most of us have seen that already. And yeah, the first learning for me was, beware of boomerangs. Huh? So it was on me to get that, to my team, to get that thing sorted. So I stepped back, did a triage, said what is working, what is not working, what can be reused, what's better made up from scratch, and kind of refine the requirements. For example, the usability stuff. As I told you, we had, it's possible to dynamically plug in nodes, device nodes, and they should be recognized, and you should be able to talk to them or to communicate with them. So his approach was, you plug that node in, and as soon as that stuff, as the node shows a green light, you can talk to it. So you had the driver or his program needed to have manual interference to being able to communicate with the instrument. So that was just going to do it. Error handling almost not there. So you could communicate with everything you liked, but you weren't given errors. Functionality-wise, if you unplugged a node from the bus, it did not realize that, and we had the optics were crap. We had frequent crashes, especially when shutting down the LabVIEW environment. So a whole lot of work to do, but I have to say I'm not going to do students bashing here. He did some things really good. For example, the interface, which I've already mentioned, with the callbacks, transforming the DLL callbacks into a dynamic user interface was a thing he really did very, very good, and it would have costed me a lot of time. So I was really happy to have that as a base. So don't get me wrong, it was not all crap. There were good things about it. So the first thing I realized was that we had to do some architectural decisions, because we have some, I like to call that asynchronous things that happen on the bus. It's, like I already mentioned, the adding of device nodes, the removing of device nodes. That's basically a callback delivered by the DLL. That has to be handled. And we have these PDOs being fired by the device nodes each 100 milliseconds or whatever. So there's asynchronous stuff going on that has to be buffered, that has to be handled without the user using the driver being without requiring the user to handle that himself. So thinking of asynchronous messages, stuff like that, being me, I chose an actor. Yet being aware that actor framework is not for everybody. So this is my first architecture I came up with. Just take the laser. So I introduced a driver API, really encapsulating everything. So this driver API looks like a traditional driver. I have an open, I have a close, read, write, whatever you want. The driver just doing the interface, the marshalling to an actor, which I call daemon, that's running in the background. The driver API is communicating with the daemon with an active framework message queue, and the data being delivered back from the daemon to the driver API or to the driver. I use single-use data queues for that. So basically, this sends a message, give me that SDO, this is the queue I'm listening to, and this one's giving it back. So that's kind of synchronous messaging, but I did not want to use the synchronous messaging from active framework. The actor itself is communicating with the DLL, with that ominous DLL. We are normal function calls, and we are these callbacks being translated to dynamic user events. To get that whole thing working, the daemon has to keep track of the PDOs being registered right at the moment to the bus, and to the and to the latest PDOs those device nodes are sending. So once you plug that device node on the bus and it's registered, it will start sending PDOs.
Remind us what the PDO is.
It's a process data object, sorry. Basically, that's a collection of 8 data bytes that are assignable, so that you can configure the node, for example, to send medium temperature, supply voltage, and stuff like that. Just do that continuously without having to call. Calling, exactly. That was a good transition. These are sent dynamically. The driver basically polls PDO values. Here, ask the actor for the latest PDO object of that particular device node, and is getting that sent back. So if I want to continuously monitor or display, for example, the medium temperature, my controller voltage, or whatever, I have to do a lot of polling. And this was something I did not like so much about that. So, in fact, I had a feature creep, originating by myself. I introduced another actor, extended the cast, who was taking care of the PDO handling. So the actor, the daemon, still receives the PDOs from the DLL, still saves them or still keeps track of them, but he also forwards them with a message to this PDO handler actor. And you can configure this PDO handler actor to send user events to the driver API, and you can configure which PDO of which node you want to receive, and you can also do that dynamically. So you can choose, while the driver runs, you can choose, I want to have device node number 16, and want to have the PDO 0, and somewhat later you can add the 1, and so that's quite handy. So at least for me.
Did you run into some issues where you have an obsolete PDO? How do you know it's the latest information?
So the question is, how about obsolete PDOs when having removed the device? So what happens is that this one, if you pull the PDO value here with that communication channel, the daemon checks if the node is still available. If it is, it will return the PDO. Otherwise, it'll be a timeout. So, and for in case you're doing the dynamic PDO transmission, it just won't be sent if the device node is not available anymore. Cool. So that's my architecture version 2. And this is my current version. Yet, well, it's working, it's still a beta, and I'm really taking care of that this beta is distributed only to assorted customers that I'm able to give direct support to. That's the reason. It's not that this thing is not working, it's running in production, and it's running really smoothly, but it's just, there are still some issues. Let's start with the issues. I still don't have a palette integration because I really do not like the way the menu file works and how you create that. And so I've just shifted it to somewhere. Yeah. As I told you, we have this the release of this terminal of this server that is used to communicate with a communicator or to use the communicator's channels. This results in being a terminal window popping up and being shown. So, like a shell window. You can minimize that, but you can't make it invisible. So if the user says, "Oh, there's a window popping up. This might be a virus." It's no virus, but as soon as he hits that and closes it, it stops working. We still have some default wait times, waiting for the executables to spin up and stuff like that. You have to dig into that. We need also, there is documentation, so it's not that there's none, but we need to have it easier. Especially, you have to dive into some can open specific things, which device node has the data at which address and stuff like that. I think I'm running out of time, right? No? Okay. That's not Warframe, sorry. So we need to have better documentation here. I have a bunch of available VIs because this bus is supporting U8, I8, 16-bit, 32-bit, float values, single precision float values, 64-bit integers, strings, and stuff like that. So, and two different addressing modes. You have a bunch of VIs in the driver to do that, all with the to communicate with the right kind of data type. And well, that's you just have it's not that obvious what to use. And still, I have this daemon that is running as a clonable. So if anybody starts this driver session again, while the first one is running, someone will crash. So there's currently no locking, no, let's say the daemon is no singleton yet. So regarding the clean code discussion, I think the red ones, they don't count as clean code related. That's just usability. But anyway, I do regard those as being clean code relevant. So we don't have to discuss about the palette integration. It's just to be done. It's a pain, but it's to be done. Documentation, check. We have to talk with our marketing guys to make that easier. Reduce the number of available VIs. That should be, starting 2017, that should be quite okay. Using nullable VIs, I'm really willing to have a look into that. Yeah, thus saying the driver itself is 2013 based to have, because we have a lot of customers using old LabVIEW versions. And yeah, the daemon as a singleton, it's not really clean to have that. So I have been asking myself then, is this really the right architecture? This is just a picture of what I've just shown you. That's my feature creep version 2.0. If you take a look at that, anybody realizes any code smells in there? Not sorry, the code, architecture-wise, architecture smells. Just shout something out. As long as you don't say it's strange colors or something like that. Now, so what really annoys me, or what during the preparation of this presentation, what really annoyed me, or what really came to my mind, I'm using a lot of communication on different channels. So it's message queues here, it's single-use queues here, I have function calls, I have dynamic user events, I have another message queue, I have another bunch of of dynamic user events. So what to do about that? As I told you, this should be a singleton, which is singleton is not the way your actor should be. I don't use any inheritance there, so the whole object-oriented approach of the actor is just not used here. So I'm using the actor framework here really only on the surface. So once again, is this the right architecture? And just wait for the animation to occur. Yeah, now Fab, it's on you. That's what I came up with. What could be a better approach? What could be a better approach? That's just a train of thoughts right now. I have to use this interface. I can't reduce this. This is given by the DLL. The DLL is fixed. But what about the interface between the asynchronous working module, which right now is an actor, and the driver API? So I could as well use a singleton DQMH here, just communicate with DQMH events. They would cover it all. Yeah? And this thing would be a singleton, which is fine. I don't need any inheritance structure, any object-oriented stuff. So I'm really considering to give this a try. At least have a little try, not the full-blown version, not the full-blown functionality, but this might be an alternative. So that's what I came up with. It could make my architecture cleaner. Conclusions. Coming to an end because it's running out of time. They are the obvious ones. Requirements are mandatory. I left this, don't give important stuff to students. And just beware of boomerangs. No offense intended, but time after time, we're all repeating this error. Time after time shows up that's is only of limited value. Okay, and beware of boomerangs. So if I had, that's my personal resume, if I had been more involved in that, I could have driven that into another direction. Still, it wouldn't have been perfect. Still, I would have to work on that, but maybe not that much. You know, you're always a little bit cleverer afterwards. So, clean code-wise, what is reading Uncle Bob's book and looking at the process? What does that mean for me, or what are my conclusions on that? Software, clean software requires craftsmanship, meaning you focus not only on functionality and not only on cleanliness, you focus it in both. So functionality is one thing, but paying attention to your future self, be kind to your future self, and to your coworkers, it's good to have a clean code that's readable and that's maintainable. It's just also another argument why maybe switching to the DQMH might be a good idea. There's two people at Berkeley being able to work with the active framework, and all the others are, let's keep it like that, there are some reservations. Okay, and what also came into my mind, you have to have the willingness to continuously refactor your code. Continuously, not in, I've saved it now, I have to watch that again, or I'm going to watch that over tomorrow, but quite regularly check it and see if the decision you took back then is still the right decision. If it's not, seek for an alternative. So let me end my part of the presentation with a rather long quote I found in the foreword of the Clean Code book. Neither architecture nor clean code insist on perfection, only on honesty and doing the best we can. It's to err is human, to forgive divine. In Scrum we make everything visible. We air our dirty laundry. We are honest about the state of our code because code is never perfect. we become more fully human and more worthy of the divine and closer to that graceness and detail. Nice one too to end with. I really like that one because it's really about code is never clean, and we should never completely clean, and we should just be honest to ourselves. And even if we have a cool implementation and it looks clean, it's never done. Shameless plug. All of you who are would be willing to go to the UK in September. There's the GDevCon happening. There will be some tickets available again. Darren, when?
Hopefully Monday.
Monday, so everybody who wants to travel to Europe, it might be worth a try to check for tickets.
Yeah, if you're registered, you might for updates, we'll have an email before their release and then we'll release the next day.
Okay, so
it's be a surprise.
So gdevcon.com, get yourself registered and you will have the email notification. Can we answer any questions? So answers to me and to Christian. Rob?
Early on, you put up a slide I was very intrigued with. It was, you said triage,
Yeah.
refactoring or redo from scratch.
Yeah.
And I have plenty of times when I've said to my colleagues, you have to start over. Nobody ever wants us to do that. And sometimes I have personal experience where I have insisted I have to just start over from scratch. It's painful, but sometimes it works out of the
Yeah. So
which did you do with this? Did you refactor or did you start?
I did refactor. So the question was during this triage, did I really refactor or did I just make everything from scratch? What I could in this case, as I have mentioned, this interface with the DLL for the callbacks, it was almost completely reusable. It was just to make it a little cleaner, to give it proper names and stuff like that it got usable. Some parts of the DLL interface for the function calls was also okay. There were two or three bugs in there, but it was usable. And yeah, I went for the fastest solution. So I thought this is working. Make it a little bit prettier, and then build on that. Does that answer your question?
Yeah.
Okay, thanks. Any more questions? No. So then, thanks a lot. Enjoy.